Here are the solutions for the solids mock exam. The right pyramid shown in this diagram has a square base with sides of length 40 centimeters, and the height of the pyramid is also 40 centimeters. What is a right pyramid? A right pyramid means that the apex, or the highest point, is directly over the middle of the base. So you can kind of see that from the diagram, even if you don't understand what right pyramid means. Okay, so this is 40 centimeters, this is 40 centimeters, and the vertical height is also 40 centimeters. It says now to find the length of OB. Let's see, we're going to draw OB in blue. OB. Okay, so we need to find that length. Okay, let's see. I have a triangle here that has OB on one side of the triangle, and it's got the vertical height of 40 centimeters on another part of the triangle. And then the only thing we don't know is this length right there. So first thing I'm going to do is I'm going to draw this triangle out flat. Okay, so I'm going to have the brown base, I'm going to have the blue hypotenuse, and I'm going to have the red height. The red height is 40. The blue one is the length we want to know. And the brown one is a length that we don't know yet, but it seems like we can calculate it. Okay, and the way we can calculate maybe is that these brown lengths, this is also a brown length right here, right? They're both the same length. They're 1/4 of the base cut out with diagonals. It turns out that this is also 90 degrees, right? So we could use that fact to figure out the length of one of the brown sides. So we know that the red side is 40, and we want to figure out one of the brown sides. So since both the brown sides are the same length, we could say that both of the brown lengths are equal to length x, right? Then we could use Pythagorean Theorem. We could say x squared plus x squared equals 40 squared. So 2x squared equals 40 squared, which is 1600. So x squared equals 800. And so x is equal to square root of 800. Let's find out what that is. Square root of 800, enter, 28.3. Okay, so the length of the brown side is 28.3. Now that we know the brown side is equal to 28.3, we could write 28.3 here, and now we can use Pythagorean Theorem to find this side. So that side would be equal to 40 squared plus 28.3 squared, square root. So we'll do square root 40 squared plus 28.3 squared. $49. Okay, it says now to find the size of the angle OBP. So let's look back at the drawing to see what OBP is. O is the apex, B is this corner, and then P is the point directly beneath the apex. So OBP would be this angle here. Okay, so let's see. We're going to redraw the triangle here. OBP. So we want this angle. We know a lot of the sides here. We know that this side is 49, we know this side is 40, and we know the bottom is 28.3. To figure out the angle here, we could use sine, cosine, or tangent. How about if we use tangent? We're going to say the tangent of OBP, I'm just going to call it theta, is equal to the opposite, this is the opposite from theta, right? It's the opposite from theta. And this is the adjacent The adjacent is 28.3, so I'm going to put the opposite as 40. The adjacent is 28.3, and I'm going to divide that, and I'll get 40 divided by 28.3. It gives me 1.41. Then I'm going to take the inverse tangent of both sides, and I'll get theta equals the inverse tangent of 1.41. Tangent is an interesting trig function because the result of the tangent of an angle sometimes gives you numbers that are bigger than 1 or smaller than -1. So the result is 54.7 degrees. Okay? 54.7 degrees. Okay? And so we know that this angle is 54.7. So it just so happens that if we know that this angle is 54.7, we could also figure out that this angle is, let's see, 180 minus 90 degrees, because this is 90 degrees here, minus 54.7 degrees. So we could also figure out that this angle here happens to be 35.3 degrees. Find the volume of the pyramid. We find the volume of the pyramid by using the formula from the formula sheet, which is for pyramids, which is for any kind of pyramid. This happens to be a standard square pyramid, square base pyramid. But with this formula, you could find the volume of any kind of pyramid at any size base. Basically, if you know the area of the base, you can use this formula, and as long as you know the height also. So in this case, we know the area of the base, which is 40 by 40. It's a 40 by 40 square as the base, right? And then we know the height is also 40. So the base is going to be 40 by 40. This is the area of the base. And then multiply it times the height of 40. Okay. So we multiply all these together, and it's 1/3 times 40 times 40 times 40, or 40 cubed. And the answer is 21333. Okay? And that's it. The units for that would probably be meters cubed. Oh no, it's centimeters cubed because it's centimeters. Centimeters cubed.